Oh, hey, this is Jeff from the Ozark Mountains. That's in Missouri in the USA. Well, you've caught me working on the guts of a TRS-80 Model 102. Somebody sent me about 2.5 of these and asked me to get one working for them, and I was able to do that, and they were nice enough to let me keep the leftover parts. This one had the batteries explode in it. You can see here that I've cleaned it up, and the circuit board works, but the display wasn't quite so lucky. I'll get you zoomed in here on the display so you can see what the problem is. Well, here's a good shot of what's up with the LCD. You notice the lines across here, and maybe I can darken this up a little bit. There is a missing stripe vertically here as well. Now what's happened when the batteries leaked, some of it got into this display, and I think maybe if I slide this way, zoom in a bit, that you might just be able to see just the telltale signs of that here. Sometimes you can push down on the frame of these and see a little bit of change, but in this case you really can't. Now typically there is not much you can do for these things, and I suspect that is what we're going to find in this case, but I thought it might be fun to go ahead and take this LCD apart and see what's inside and see if there's anything we can do about it to recover its operation. Let's have a look at that. Okay, here we've got our LCD unit off, and we've got a metal frame here which just has these little feet that are kind of twisted over, and it applies pressure. And these are all the individual driver chips for different parts of the display. To make everything work out right, they've done something clever. They cut a hole in the board, and they took one of these chips and dropped it upside down and dropped it in the hole to make everything fit. What we'll do is we'll twist all of these things off of here, and then we'll try to take this apart, and we'll have a look-see at what's inside. I think I'm going to use these lineman's pliers here. I'll try not to drag the pliers across the circuit board, gripping onto that little foot just above the circuit board. I'm also keeping a little downward pressure on the board, so when it comes apart, we can try to avoid everything shifting on us. Okay, there we go. It is all loose now. So I'm going to turn it back over like this. And since this frame looks the same, I'm going to write B on this side. I had labeled all the individual computer parts the fellow sent, A, B, and C, so I could keep them apart. Okay, so take that frame off of there. And that looks okay on the inside. And we have our LCD glass here. And it's hard to see because of the reflection from my overhead lights. You can see the reflection of the glasses on my t-shirt there. So take a look at the reflection of my t-shirt and guess what TV show that's from. Anyhow, you see this little gray rubber piece right here? That's the actual contacts going from the circuit board to the LCD. That's oftentimes referred to as a zebra strip, and it is layers of conductive and insulating silicon rubber in this orientation, and the thickness of the conductive part is such that it should make contacts on the pads on the circuit board and up to the LCD without shorting two segments out. And it looks like, to try to get a reference on lining this LCD glass back up, that right at these slots right here on both sides is where that goes. And as far as vertically, that's going to be a little tougher. So we'll just have to do the best we can there. And you can already see that that zebra strip is drooping. It's peeled off to about right here. You can see that zipping along there. Just giving it time. Don't want to break it. Little mark on the glass to denote that it's up in that corner. Yeah, okay. Now I think we got it. Okay, got the glass off of there. Let's have a look at the circuit board first. Right here, you can see a little discoloration. Right here. I think that's just from the edge of the board. Oh, wait a second, look at that. I think we completely lost one there. That's not good. Let's look at this top edge now. There's a little discoloration in this corner. Okay, so I think this corner looks like the worst of it. Yeah, this part of the zebra strip would correspond to where we saw the discoloration on the strip, and I don't see anything except for maybe here. Okay, so we've got a really bad spot on the board right there, and that lines up with this funny looking spot on the rubber, and it looks kind of corroded here, so I think we had some of the battery splints get in here and eat that trace off. And I don't know what we're going to do about that, but we'll give it a shot. First thing I'm going to do is take a pencil eraser really lightly to these discolored traces, just like this. Just try to polish them back up. And now that I've got all the contacts here wiped very, very lightly with the eraser, I'm going to take some alcohol and a cotton swab and just clean all those pads off. Now I'm going to do the same thing with the zebra strip. Okay, I've got kind of all around the zebra strip cleaned up as best I could. And those are feeling really well adhered to the glass, so I don't think I'm going to try to take them off. Do a second cleaning, and then we'll try to fix the circuit board. Here I'm shooting through my lighted magnifier, and you can see the problem. This trace that went up here is no longer connected. This one may not be connected either. These other two come from this direction, and that one looks connected. So perhaps it's this one and this one. I got this cleaned up, and this pad does connect to there. This one, of course, doesn't connect to here because there's a big chunk of it missing. And I used this fiberglass pin, a tip I learned from Gadget UK, to clean that area up after scraping this solder mask off there with an X-Acto knife. So now we're going to figure out how to replace that missing pad. Okay, here's the best I could come up with. I have some of this self-adhesive copper foil, and I tried to take some scissors and cut really thin strips off of this, and it took about 10 tries to get it right. I cut a really thin strip off, stuck it on there as best I could, and then soldered it onto that via. It's a little wider than what would be ideal, and it's not stuck down very well, but I figure it's going to be pressed on by that zebra strip, so maybe it'll work, maybe it won't, but we'll give it a shot. Okay, it is back together. Now the big question is, will it work? And second big question is, did I put the right part in that corner? I think I did. Okay, here we go. First try since we attempted to fix the screen. And we fixed this stripe. Yep. What we did there was fix that little stripe. It didn't do anything with these horizontal rows. Well, that was actually a heck of a lot better than I thought we might do. So I'm wondering if this is more of an issue with one of the chips. Let's try to push on the chips. They're not making any difference with squeezing it. So maybe we'll have to look at what's driving the rows. See if we can figure that out. But it's a lot more improvement than I thought it would do. A little handheld shaky cam here. So we fixed that one little missing vertical spot, but we still have 3 missing rows. And after studying the schematics for this LCD, it looks like this little chip here in the corner and this one in this corner take care of driving the common for the rows this way. And all of these other chips do the columns. So when we fixed the one connection down here, that was for that little section of column. And I believe this chip right here does row 1 through 20. And this one does 21 through 32. So I've taken the scope and measured all the outputs, which I believe are the row common drivers. And there's signals there, but I'm not sure where they route to exactly on the circuit board or how they get to the LCD. So I've got no other choice now but to take this thing back apart and hopefully not mess it up. So we'll see what happens. Okay, so I took this guy back apart again, and luckily a little patched in pad right here stayed in place somehow. And what I found from looking at these two common driver chips is that they run to the 4 corners of the board. And these run here and here, and there's a few of them that run over to here, and these run here and here. So they're coming out at different places on the board. And if I remember right from the video Dave Jones on the EEV blog did about LCDs, they want the commons coming out in different places so you don't have as large a voltage drop. I toned out all the connections to each of these pads through all the vias, and all that seems fine. All the pads seem perfectly fine. So I think this part is okay. One thing you can see on this board is that there's a little gap here between the segment drivers and the common drivers, which I hadn't noticed before. So anyhow, I think this part is okay. Here is our LCD glass, and I noticed that I'm guessing these areas right here are the commons. So it seems to be going from these areas where the common contact is to these dots and across. So my only guess is that there is a contact area under here, or it's in the glass itself, which we wouldn't be able to do anything about. So now I will peel these rubber strips off of here from the corners and see if there's any goo or anything underneath there. Okay, well, I took it apart a couple more times, tried to clean the zebra strips again. They seem to be glued or very well stuck to the glass, so I stopped trying to peel them off there. I've seen others where the strip comes off and you can clean, but I'm not sure about this guy. So I mentioned I've completely botched it now, but we'll see what happens. Well, it's no worse than it was before. Either it's not a connection problem or the LCD's bad, because I'm squeezing in the corners here where those commons connect. Okay, you might be noticing that we have the stripes at the bottom of the screen now. Ignore the vertical lines for now. We don't have the stripes up here anymore. What changed? Well, on a whim, I took the LCD out and I spun it around 180 degrees like this. So this corner used to be here, and that in the line switch. So this is telling me that either we have a bad connection between the zebra strip and the LCD, or the LCD's bad. I'm betting the LCD. So I'll take this apart one last time, and I'm going to peel the zebra strip completely off this end and rotate it side to side and clean it really good and make sure the LCD is back around the right way. I don't think that's going to do any good. I think we have a bad LCD in this case. I took this back apart. I rotated the glass around to its original orientation. Then I pulled both zebra strips off, cleaned both sides, cleaned the contacts on the LCD, put it all back together, and we still have our original dead stripes in the same place. So that is definitely a fault in the LCD glass itself. And all these vertical stripes here, that's just because I've taken it apart and put it together so often that we're not making good contact on this edge. So what have we learned? We learned that the LCD is interchangeable. You can rotate it 180. It's just a simple matrix arrangement. We learned that all the driver electronics on this display board are good, so we can use those for spares. We learned that we could bodge a missing pad and it will work, at least for a while. And we learned that, not every repair is going to be successful, but you can learn something in the process and you can have some fun. So, thought we would have a quick peek at the Model 100 LCD and the 102 LCD that we've been tinkering with. And as you can see, these are just about the same. The connector's different. It's got the same basic display driver chips. They used a surface mount part here on the 102 as opposed to the through-hole part here. And there's a few odds and ends, resistors and capacitors that are in slightly different places, but basically this is the same exact design. Okay, here's the front of both, and excuse the reflection from the overhead lights, but you can see they are basically the same. The frames are a little different. The connectors here is different. And looking at the LCD itself, it looks the same, which makes sense because basically these are the same unit. So it makes me wonder if it would be possible to take the LCD glass out of a Model 100 and put in a 102 or vice versa. I'm not going to attempt that because this is a good Model 100. I just wanted to have that peek and see, but that might be a possibility. Trying to put two partially broken machines together and make one good one is to swap the LCD glass itself. Got the 102 back together. I borrowed a few little bits from some of the other parts machines, and this one's mostly complete now, but the LCD still doesn't work. I couldn't stand the fact that I actually made the LCD work, so I took it apart again, just like the 8th or 10th time, and fooled with the zebra strips, and I found that when I positioned the LCD glass on top of the circuit board and aligned it, that there looked like there was air pockets between the LCD glass and the zebra strip. So I took a rag and very carefully rubbed down both edges right above the zebra strip. This is, of course, without everything back together. And anyhow, rubbed down each edge of the glass, right on the glass, and that seemed to seal it well to the zebra strip. And now we're back to just our original 3 missing rows, and our fixed column still works okay. Well, how'd we do? We did make a slight improvement on the LCD on this 102. Learned a lot in the process. Got to take it apart several times and learned it can be put back together and work. Got really lucky with that pad repair. I'm still kind of amazed that actually worked. And we found out that the LCDs in the Model 100 and Model 102 are darn near identical. So maybe it's possible to swap the LCD glass between them. That remains to be seen. As you can see, not every repair attempt is successful, but hey, it's fun and you get to learn a little bit in the process. While I had this Model 100 apart, I realized that capacitors are starting to leak and it does need to be recapped. And it's still got the original NiCad battery, so that's something I'm going to have to take care of. So maybe we'll see that in an upcoming episode. I'd like to take a moment to say thanks to the folks who support the Hey Birt channel by Patreon and other means, and to everybody who tunes in and watches each episode. I really appreciate it. If you'd like to find out some more about helping to support the Hey Birt channel, you can look down in the description below and you'll find the Patreon link. Now, if you're a subscriber, I really appreciate it. That helps a lot, and it helps other folks find the channel too. If you'd like to subscribe, well, look down below. You'll see a rectangular button that says subscribe, and it does what you suspect. It subscribes you to the channel. And then click on that bell icon, and YouTube will be nice enough to let you know just as soon as I post a new video. If you have any questions or comments, I sure would love to hear from you. Just leave them in the comments section down below. Well, until next time, bye.